In this unit, we're talking about systems of equations. So we've got to start and go back to the beginning and review how to solve systems of linear equations in two variables. So when we're looking for two variables, an x and a y, we'll always have two equations. When you have three variables, you'd have three equations, and so forth. So the first thing we want to talk about is, what does it mean to be a solution? So if it is a solution, it'll satisfy both equations in the system. In other words, if I plug in these points, it'll be true for each one. So if I plug in x negative 1 into the first equation, I get 4 plus negative 2, and that is 2, so that checked out. On the next one, 4 minus 2 times negative 1, that would be 6. It checks out. Now, we already know what's going to happen here, but let's go ahead and just work through it. So negative 4 plus 2 times 3, that's 2. Negative 4 minus 2 times 3. This one didn't. So notice it did work in one equation, so that point is on this line, but not on this one. The point has to exist on both lines. Now, there are a couple of methods that you learned way back when. Graphing was one of them. Now, graphing is not always the best option, especially if your answers are decimals or fractions or things like that. So we're going to review the algebraic ones. Well, because we're in college algebra and we're going to do it algebraic. The first method we're going to review is substitution. The first step in substitution is to solve either of the equations for one variable in terms of the other. So we're going to look and see which variable would be the easiest to get by itself. So I notice this x has a coefficient, this y has a coefficient, but in the second equation, that x does not have a coefficient. So I'm going to bring that over to the side, and I'm going to solve for x. In other words, get x by itself. Now that I have x by itself, I have an expression that is equal to x. What that tells me is that anywhere I see an x, I can actually replace it with this expression. So let's look at equation 1, the one we didn't mess with. What this means is this x, since this is what x equals, I can replace this x with 2y minus 3. And I always replace it in parentheses because you're substituting it in, so keep those parentheses. Now, when we do that step, we end up with one equation and one variable. So I would distribute, combine like terms, add the 15 over, and I get y is 4. Now, I'm not done, because we are looking for a point, an x and a y. But I noticed that that equation was already set up as an x equals. Now that I know what y is, I can plug it in. So that would be 2 times 4 minus 3, which is a 5. So the solution is the point 5, 4. Now that method is great most of the time. But sometimes when you have a lot of coefficients, when you try to solve for one of the variables, you end up with a lot of fractions, and it can get very messy. So the other method is called elimination. It's where if you add the equations together, one of the variables adds to be 0. So sometimes we have to multiply one equation by something We may even have to multiply the other equation by something different, but we're trying to set up so we have opposites. So you can choose either one. I usually notice if I've got opposite signs. So I have a 2 and a negative 8. It'd be really easy to change that 2 into a positive 8 by multiplying that first equation by 4. So I'm going to take this first equation and I'm going to multiply by 4. And that's going to be 4 times 3x is 12x plus 8y. And then I need a calculator for this part. That'd be 192. And I don't have to do anything to the second equation. Now, sometimes you have to do something to each one. If I add these together, notice 8y plus negative 8y, that's going to go away. That's my whole mission. We are trying to eliminate. And one thing I like about the elimination method is after that step, it gets solving for the first variable is super easy. So I get x equals 8. Now I'm not done though, because we still need a whole point. Now we can plug this back up into either of the given equations, these first equations. I think I'm going to choose the first one. So I'm going to take that x value and plug it in. And now we're just solving a simple linear equation. And my solution would be the point 812. Let's try the next one. Okay. Ooh, we're going to have to do something here. We've got a 4 and a 6. I can make them 12s. Well, what if we make the top one a positive 12? So I'd have to multiply by 3. And I can make the bottom one a negative 12 by multiplying by negative 2. So I'm going to multiply everything in the equation, both sides, by 3. So I'd have 12x plus 18y equals 36. Multiplying the second equation by negative 2. So I get negative 12x minus 18y equals negative 24. Ooh, something interesting is happening here. When I add, I'm getting a 0 for both of those. So I get 0 on this left side and 12 on the right. My variables went away. They disappeared. 0 equals 12. Does 0 equal 12? No. That's a false statement, which means no solution. Let's look at the last example. When I see this, I notice that I already have a y equals. So this one is set up great for substitution. If I have a y equals, I can replace the y in the other equation with what y equals. Always substitute in with parentheses. Because our next step is to distribute. And I end up getting x equals 15/2. I end up getting a fraction, or you can make it a decimal, but that's okay. Let's go ahead and plug it in. And I end up getting, or you could get the decimal, but the point is the solution. So make sure we find the whole point, the x and the y.